All right. Good day, everyone. Depending upon when you're watching this, it's either good morning or good afternoon, or for some of you, hopefully you're having a good evening. Again, remember that anything I'm introducing right now is just an extension to prepare you for next year, to prepare you for standardized testing. The one thing that you have to make sure that you're still doing is, of course, any of your late work. I have not updated grades, although I have received numerous things in my email. The only reason I haven't updated grades is I don't have enough from a number of you, and I'm trying to still give us a little bit of wiggle room. But very soon, some of us are going to see the grades going in. Some will be happy, some will not, but just keep that in mind. So with that, again, circles is our enrichment. I want us to be able to go a little bit further. We all talked last week about some basic vocabulary where we did talk about the center of a circle. We had radius, diameter, chords. So we did introduce that information. Today, what I want to introduce is just a little bit of vocabulary that comes down to our segments still, and one of which is considered a tangent segment or a tangent line. And typically what happens is it looks like it skirts just the edge of our circle, and the idea is that it just touches at one point. So no matter how good or bad the drawing is, understand that in the directions, because this is kind of sloppy, in the directions it will tell you that you have line AB, and again it will tell you that AB is tangent. Now it is not necessarily the same tangent that we just got done talking about in the right triangle chapter. It has a lot of the same references. For instance, the first reference is that with our radius, and there's an infinite number of radii, so there will always be a radius that touches, and it will touch at a right angle. So there's something to kind of think about, the idea that a tangent in our last chapter dealt with this adjacent and opposite sides, the legs of the right triangle, where the hypotenuse is always opposite the right angle. So you can see where there's a little bit of a crossover, but that's not necessarily, we're not talking specifically about opposites over adjacents. We're talking about this line or this segment. So when we define tangent as a definition, a line or segment that intersects the circle at one point and is perpendicular to a radius. Now notice I didn't say the, because there's a number of radii, so it will be perpendicular to a radius. So what that also then means is if we were to connect, so let's just call this circle P, capital P, if we were to connect that segment, notice how we do have a right triangle in here. So that is where, again, with our right triangles, we have to remember that we now have the Pythagorean theorem, we have special rights, we have trig. So anything that we have done now with our right triangles will apply here, so we cannot just disregard. All right, so make sure that you're paying attention to when it's tangent, it is specifically bringing in this right angle idea with a radius. So let's talk about what that's going to look like. Let's give one example. So is AB tangent to circle C? And we're going to draw our circle. Here's our center, circle C. We're going to draw AB here. And here is our radius. Here is this, and I'm going to tell you that the radius is 8. That out here is 9, and over here is 12. Now I changed the question up a little bit because I want us to use our minds, and I want us to not miss, again, we brought it up on Wednesday, how much we can hide and we don't even realize. So let's not forget that if we have a radius here that's 8, we're going to have a radius here that's the same value. So 8. And if this is supposed to be tangent, if tangent, then the triangle that's been formed, triangle CAB, should be a right triangle. And our right angle has to be would have to be at A. So what we're going to look for is we're going to test using the Pythagorean theorem, is this actually a right triangle? So here's C, here's A, here's B, and we want to know, is this guy really a right angle? Or is it a right triangle? So we know this is 8 and we know this is 12. What we can't forget is all the way across, even though they only told us 9, we're not going to put 9 here. That can't be. That angle's way too big for 9 to be here and 12, being a bigger number, not there. So remember, that's 8 plus 9, which gives us 17. So now we're going to test the Pythagorean theorem. 8 squared plus 12 squared, what is its relationship, notice my question mark, to 17 squared? Well, we know that this is 64 and that's 144, and is that going to be the same as 289? Well, 4 and 4 is 8, 6 and 4, I end up with 208. That's, oops, great job, Caffarel. That's smaller than 289, which tells me, why did I say? Somebody help me. I'm going, yeah, 289. And 64 plus 144 is, I can't even add today. My calculator did that, is 208. So what we just found out is this is actually an obtuse triangle. So when I answer this question, I would answer as no, it's not tangent. Oops. To circle C. Almost made another triangle. So make sure what we're doing is in these situations, we have to remember that because of the right angle, we have the right triangles. So now we can utilize our Pythagorean theorem for that. I will tell you that the irony of this is we got our daughters a pool, and I was trying to figure out how to place pieces around the pool to kind of hide some of the parts of the pool, and I was trying to measure it very similar to this, and finding that it just is going to cost too much. But I laughed that I was actually using tangents to see how I could place pieces around this pool so that I would have enough boards and it just wouldn't work. But I thought it was interesting because I was using geometry in my backyard just yesterday. So we're going to look at one more idea with tangents that don't necessarily have to do with right triangles. And it kind of always reminds me of an ice cream cone, kind of. And what happens is there is a rule that says, that's a pretty good circle, if you have two tangents that intersect outside of your circle, I tried to do that as perfect as I could. So we have a tangent here, and we have a tangent here. And it does say that if two tangents intersect outside of your circle, so notice how when they intersect, they're outside of the circle, they will be congruent. So what we're looking at is if I have circle C, and we have, for instance, this side is 7x minus 2, this side is 3x plus 8, and the question could simply be, solve for x. You already know that if we're going to solve for x in the directions, so our given statement would have to tell you dA and BA are tangents to circle C. Solve for x. So again, they're telling you, I'm telling you in the directions that they're tangents. So now you know that this rule applies. So you're simply going to 7x minus 2 equals 3x plus 8. Subtract 3x. Add 2. And when we divide, you end up with 10 divided by 4, which is 5 over 2. So you find out that x is 2.5. Now, don't be surprised that, of course, one of the things that could come up is this idea that they can bring in any kind of problems when we're setting equal to each other. So again, using the same information, So B, A, D, C. And I'm going to tell you now that this is x squared plus 25, and this is 10x. And of course, our brains go crazy because we see the x squared in there, and what we have to remember is that anytime you have something squared and you have something to the first power, you will most likely end up dealing with a quadratic. So we have to bring back our Algebra 1 knowledge, which is good because we need to have this ready for Algebra 2, that if we do have the idea that they're tangent, that means they're meeting outside, that means these two are congruent. So now what we have to remember is we're still going to set them equal to each other. That's not going to change. The only thing that changes is we have to change how we solve. So don't forget that when you have a quadratic, you need to bring everything to the same side of the equal sign. And you can factor to solve. You can use the quadratic formula to solve. In Algebra 2, we're going to look at a couple different ways besides those two to solve, but the quadratic formula is on your formula sheet. It takes a bit longer, but it is foolproof. It works in every situation. If we can factor to solve, what we'll find is it actually goes faster. So again, it's not needed, but it is much more efficient. And notice where I wrote that minus 10x over here. I kind of shoved it between because we have to also remember that when we write any polynomial, any multiple term, we count down our powers. So 2, 1, even though we don't see it, and then none, and we set it equal to 0. And here's where we go, okay, what are the factors of 25 that when I add them up, add up to negative 10? So when we factor, factors of positive 25 that add up to negative 10. And hopefully, while you're thinking about all of this, you're saying, well, negative 5 times negative 5 would be a positive 25 because a negative times a negative is a positive. And negative 5 plus negative 5 is negative 10. So notice my parentheses showed up. We now set each of these equal to 0. It's called the zero product property. And we find out that in both cases, it's x equals 5. So in this case, we don't have two answers. If we did, we would have to test to make sure they worked. This case, we have what's called multiplicity. It shows up more than once, but x equals 5. So again, just going a little bit further with our circle chapter. When we come back on Wednesday, I'm going to give you a little bit more vocabulary. Please continue to be emailing me your information. I will continue to update and grade. I will be updating scores here probably before the end of the evening, so keep a lookout for that for tomorrow. If you have any questions, I have not received any questions except from maybe one person, and I think that was Algebra 2. But I am receiving a lot of work, so you can start to see those updated now that there's a number of you. So keep working hard, keep staying motivated, make sure that you are not just sitting inside. Get outside, enjoy the weather. It's beautiful, get your mind right, let's get moving. You guys have a great day, and I will talk to you again